All right, so we've got 2.7. It says derivatives of composite functions. What that means is that we're going to learn something called chain rule. It's great. Before we do chain rule, let's do the bell work, shall we? So, if you're doing it at home, pause it, try the bell work, and let's go through it. Find the equation of the tangent line to h of x if h of x equals this thing when x equals 2. If I'm going to do that, and it says the tangent line, what should I immediately be thinking? What are the two things I need? Pot and sock. Exactly. So we're going to find our pot and our sock. Exactly. And our point of tangency is going to be 2 and h of 2, right? So I'm just going to plug 2 into here. If I plug 2 in, what do I get? Well, yeah, so 5 on the bottom and what on the top? 2. So I get 2/5. Then I'm going to do the slope, which means that if I'm going to find the slope, I need to find the derivative, because the derivative is the slope of the tangent. Okay? So I'm going to do that. Now, how many of you guys remember quotient rule from last class? 1 person. Excellent. 2. Thank God. All right. So remember, we had low and high. And what we do is we do low d high minus high d low over low squared.
But that's the same as u and v.
You could, yeah.
And how would you put UV there?
Let's say we did u and v. Then it would be v u prime minus u v prime over v squared. Okay? All right. So we're going to look at the bottom one. Low, we just write it out. Now, what is the derivative of x? The d high. Not a trick question. Not 1. There we go. It's 1. So I don't even need to write 1. Minus high d low. What's the derivative of that bottom function?
1x.
Close?
X.
2x, right? Because the 2 has to come down, right? So it'd be 2x all over x squared plus 1 all squared. Now, normally you would, from here, probably simplify the numerator. But if we're plugging in 2, it's kind of a waste of time. So what we can do is immediately just go to plugging in 2 for all my x's to solve it. So, yep. Yeah, this is just for the sum. So, what is 2 squared plus 1? And then 2 times 2 times 2, because we're going to replace the x's with 2. 8. And then we already said this was 5, so 5 squared is 25. And so we're going to get that this is negative 3 over 25. So that's my slope, or my SOP. And then I simply need to write it into my point slope form so that I have the equation of the tangent line. So y minus 2/5 equals negative 3 over 25 x minus 2. Do I need to simplify that? No. Could I? Yes. If the question specifically said write it in, y-intercept form, then yeah, you should. But I'm not going to, like y-intercept form. But I'm not really going to do that, so you're okay. You can just leave it like this. Say what? How do you simplify this? You would multiply the 3 over 25 in, and then move over the 2/5 to make it y equals mx plus b. But,
Sir, can you give us a study guide for that?
I don't know.
I don't understand.
Okay, then I probably can. Alrighty, so now what we're going to do is we're going to learn chain rule. So, just like before, when we do chain rule, we're going to do it 2 ways. We're going to do it by turning it into a polynomial, and then taking the derivative, and then we're going to actually do chain rule and show that it's the same. And I think you're going to like this one because in this case, chain rule is actually just easier and faster than even doing the polynomial. Whereas for the last two, you guys will go, why did I bother? Right? It wasn't any easier. Well, there were still reasons if you mix things with trig or something like that. Here, it's just easier. So let's do it the long way first, where we turn it into a polynomial. So we're going to rewrite this as 2x plus 3 squared times 2x plus 3. Where are you going? All right, show me the email. All right.
You don't have it.
No, they don't send it to me. It's stupid. That's why you got to show me. So, the perfect square, that's easy for us to do, right? Our perfect square is just going to be 4x squared, because it's the first term squared, plus twice the middle term, which means we multiply 2x times 3 for 6x, and then double it to get 12x. And then we square the last term to get 9.
How did you get the 12?
Because when you're doing a perfect square, it's 2x times 3, and then 2x times 3 again. Because remember, outside and inside is exactly the same. So we just double it.
Not yet.
All right, write it out the long way then.
No, but Mister, what it was 3.
Oh, look, I'm going to write it out the long way for you. So when you do FOIL, the first is what gave me the 4x squared. Then you do the outside and inside. And if you look at them, it's 2x times 3 and 3 times 2x. So I'm literally going to get 6x and 6x. And then I do lasts, so 9. So when you're doing a perfect square, the shortcut is to just multiply the middle term by 2. Okay? So all you do is you take that 6x and you say, times 2, because we know it's going to double. So that's how I got this. Then I need to multiply my 2x into everything. And so I'm going to get 8x cubed plus 24x squared plus 18x. And what do I need to do next to finish multiplying these? The 3 in, yes. I'm going to multiply the 3 in first, and then I'll simplify my x's. Okay, so 3 times 4x squared is going to be 12x squared. 3 times 12x is going to be 36x. And 3 times 9 is going to be 27. Then what I can do is the last step is to put my like terms together, gather everything. So 8x cubed, there's nothing. Then I've got my squareds, so I'm going to add those together to make them a single term. And then I'm going to put together my x's, which is 18 plus 36, or 54. And last is the 27. So now that I finally have it looking like a polynomial, what can I do? I can I can find the derivative, the prime, by just using power rule. So the 3 comes down, and this becomes 3 times 8, or 24x squared. The 2 comes down, and I get 72x. And then here, this is just 54. And then the 27 goes away, because the derivative of a constant is 0. Okay. Now, let's figure out what chain rule is and see how it's actually easier. Why not? So, h of x, if we define it as f of g of x, meaning it's a function inside of another function, right? A composite function. Then what happens? Yes, exactly. It's like fog.
That's the.
Yep. I'm sorry.
I never passed that.
Uh-oh. Well, that's going to be tough then. So now what we're going to do is we do the derivative of the outside, which is f prime. And then we multiply it by the derivative of the inside function. And that's all we need to do. So to write that out, because I think it's actually more helpful to see it written that way, is it is the derivative of the outside function times the derivative of the inside function. The key thing here is to note, because what students will do is they'll try to take the derivative of both at the same time. If you look here, that is not what we're doing. We're taking the derivative of the outside times the with the original inside. Then we multiply by the inside. So you do not take the derivative of both and be done. You have to take the derivative of one with the inside still there, then times the derivative of the inside.
That
So-
star means times, right?
What? Yeah, means times, yeah.
So we need to first get f times g of x.
It's not times. It's f of g of f prime of g.
So we get f prime of g of x.
Yep.
Mas e que é
Okay, I'm gonna go through it. I'm gonna go through it. Ready? Watch. So if we think of this one, what would be like the outside function? And if we want, we can rename these. So like, what would be my f of x, the outside function here? No. The 3 kind of, it's the something cubed. It's literally something. It doesn't matter what it is. It's just something cubed. So if I took the derivative of that, then it would be 3 times the something squared. Because it's literally, it's just like taking the derivative of x cubed. And it would be 3x squared. The difference is that x is now some function. It's not just x. Okay? So that's my outside. And then I need to multiply it by the inside. So that's like my g of x function. And in this case, what is inside of the something cubed?
2x plus
Exactly. 2x plus 3. And what's the derivative of that?
2.
Exactly. And those are my inside functions. Does that make some sense?
I'm very
The inside is
Did you just say you're very addicted to crack? What did you say?
very attentive in class.
Very attentive in class. All right.
I'm waiting the present account.
Well, I just realized too I'm recording, so that's now immortalized on YouTube. No problem for you because you're clean.
So I understand the inside, but I understand the something.
The something is just whatever's inside, whatever it is. I'm writing something because I don't want you to get confused and think it has to be 2x plus 3. It could be anything. It's just whatever's inside.
I thought we should find like that word. Something.
I see, no. Okay, so now to do this, right, I take the derivative of the outside, which we already decided was 3 times our something, and in our case, this is the something. So 2x plus 3 squared. And then I just multiply it by the derivative of the inside, which is 2. Now I would probably simplify that and write 6 times 2x plus 3 squared. We're done. So if you don't go through writing all this on the side, which you're not going to need to do all the time, this is way faster than turning it into a polynomial.
Why
Yes.
didn't you multiply the two for the things in the parentheses?
Well, I would eventually, but I'd have to I'm just simplifying it by putting the coefficients all in the front.
Okay.
If I want to put those inside to the parentheses, I'd have to square it first and then do it, because I have to do PEMDAS, right? Now, let's, you don't have to write this, well, no, let's write it actually, I do want you to. Because what we're going to do is, normally we'd stop there, but I'm going to keep going so that we can see it's the same. So I'm going to square this again, which we already did. It was 4x squared plus 12x plus 9, right? We just did that in the last question. And then I'm going to just put my 6 into that parentheses, or into that bracket. So I get 24x squared plus 72x plus 54. Where did I get? I just squared the 2x plus 3. Right? 2x plus 3 squared is this. Remember we did it up here. That's why I wrote it quickly, because we already did it. Remember? And so then I just put in the 6 to get this. And at that point, you should realize that's the same. And I can't write. Samesies. Right? It's the same. Just like we've done for the other ones.
Mister, why is that the derivative of the f of x is just 3?
Well, it's 3 something squared. And in our case, it's 3 2x plus 3 squared.
So we need to find that derivative of the outside.
Uh-huh.
It will be the exponent down, like at the beginning, something, and squared over.
Exactly. Yep. That's exactly right. So, why don't we try applying this to some questions? So let's try to do this without writing outside, inside, because then takes so long that it's not really helpful as much. Still lets us do it, but it's not as helpful. So if I'm trying to do f prime, I need to take the derivative of the outside. What is the outside function here? Yeah, the something cubed again. So that's just going to be 3 times our inside squared, right? I just did power rule on it. That's all I did. And then I need to multiply it by the inside. 6x. Exactly. And so just to kind of highlight that for you, here's our outside. And then we multiplied it by the derivative of our inside. That's all we did. And again, you should simplify and put like all these things at the front. And so I would write this as 18x times 3x squared plus 2 squared. And that's it. So the chain rule is pretty easy. Okay? Now, it is a little bit trickier when we have like certain things, and this would be an example. But it's not terrible. We just have to remember our exponent rules for radicals. So we can rewrite this as 2x plus 5 to the power of a half. And now we can treat it exactly like the previous question. It's just that we have a fractional exponent. That's the only trickier part. So the outside function this time is not something cubed, but it's something to the power of what? 1/2. So we would bring down the 1/2, multiply it by the original inside function, and then to the power of 1/2 minus 1. Because remember, you always just subtract 1, right? That's the power rule. You bring down the exponent and subtract 1 from the exponent. Here, it was just easier because it was whole numbers. The 3 came down and 3 became 2. Here, the hard part is that it's a fraction. So 1/2 becomes negative 1/2.
So with every fraction, we just put
But it's not necessarily going to be the same fraction. You have to actually subtract. Because if I had like 2/3, well, 2/3 minus 1 would give me negative 1/3. So you do need to actually subtract 1 to figure, and you can use your calculator. Okay? Now I got to multiply by the derivative of the inside still. What's that? 2. And what cancels there? 1/2 and 1/2 and 2, right? Now, you could leave that as your answer, but usually...
Why is that the derivative of the inside 2?
Because what's the derivative of 2x plus 5?
Exponent.
Right? The 5 disappears, and the derivative of 2x is just 2. Now, usually you guys, you shouldn't leave it with a negative exponent, and so what we do is we cross the line, and then we flip the sign. And so this is how you should write it.
And why do those and two cancel out?
Because it's 2 over 2, which is 1. Right? 2 divided by 2 is just 1. So that's why we can cancel them, and they become... It's not that they're like gone, they just become 1. They simplify, is a better way to say it. Okay. So that's it. That's the rule. So the only thing that can make this harder is when we start kind of combining things. And so we're going to do that here, where we actually have 3 functions. We have an outer function, we have a middle function, and we have an inner function. I want you guys to take a look at it and see if you can tell me which one's which.
I can't.
Huh?
So outer is sin squared.
No,
Yeah, it's something squared is a better way to think of it, but yes.
Squared, how would you want to say it?
Sure, we can say sine squared, yeah.
The inner is 2x plus 1, and middle would be both of them combined, but without the square.
Yes, exactly. The middle one is the trig. So the middle one is sine 2x plus 1, right? Because the outermost function is the something squared. Inside that, we have a trig function, which is always going to be chain rule. The reason you didn't do chain rule earlier is because what did I always put inside the trig up until now?
Exponents.
Kind of. Like inside, like as in like this part here, what did I have before?
Theta.
I just had theta or x. What's the derivative of theta? Or x? 1. So you did chain rule, but who cares if you're multiplying by 1? Like it doesn't change anything. So you were doing it, it's just that I didn't tell you because you were multiplying by 1 and
Mister,
that doesn't
gonna
matter.
ask about sin and cos in the exam.
I'll ask a little bit, yeah.
No.
So you should teach us again how to find that there.
Yes.
Because I don't understand.
Well, I've got the derivatives written on the wall for you.
But which one are they?
There's some there, and most of them are over there too on the middle yellow. So they're on the wall twice. All right, let's try and put this all together then. So it's the derivative of the outside, so that would be 2 times the function to the power of 1.
Wait, out.
Right? That's the outer. If I was to highlight it, this part here would be our outer. Then I'm going to multiply that by the derivative of what's inside, which is the sine function.
Mister, you put that something squared, right?
Yeah,
That's why you just put.
yeah. I did the derivative of that something squared. Because sine squared became 2 something to the power of 1.
The inner
In y
is just
to the power of 1.
Well, because like if I had x squared, the derivative is 2x to the power of 1. We just don't write the 1.
Mister, but the inner is just 2x plus 1. We didn't put cos.
Well, because that's the middle function.
How we have to multiply it?
We got to do all of them because that's the middle. And now I need to still multiply by the derivative of the innermost function, which is just 2. So we took the derivative of the outside times the derivative of the middle times the derivative of the inside.
Yeah, but Mister, how I don't understand the first part. Why 2 sin to the power of 1?
This part? Because the outer function is just something squared. So something squared
Something.
becomes
Okay, yeah.
2.
because we were doing cube, so cube is 2.
Exactly. Whereas now it's squared, so it's just to the power of 1.
Okay, yeah.
Okay. And then the last step is going to be to combine those coefficients here and go 4 sine 2x plus 1 times cosine of 2x plus 1. And that would be our final answer. Whew. And so, like I said, this is the only way to make this any more like complicated is to combine them. So here we did a chain rule of a chain rule. Well, we could also combine like product rule and chain rule, or product rule and quotient rule, or quotient rule and quotient rule, right? Like you could combine these rules. And that's the only thing that can really be done to kind of make this more complicated.
We can use this one instead of the quotient rule and the other one, right? Or each of those are from different.
You have to use them like product rule you need to use when you multiply, quotient rule you need to use when you divide, and then chain rule is whenever you have a function inside of a function. This is probably the one you'll use the most, is chain rule, most likely.
You're gonna give us
Like that, pretty much.
Yeah, it's the derivative of the outside times the derivative of the inside. Yeah.
You're gonna give us the equation and like some.
Yep, they're written on the wall and I'll write them on the board if you want. Yeah.
Because I don't find everything.
That's fair. So if you look at this one, what are the 2 rules that we're going to need to apply? Are things multiplied, divided, or are they fraction? Like not a fraction. Are they multiplied, divided, or are they inside of each other? There is definitely going to be a chain rule. That's correct. So we're going to have chain. What else? Exactly, product. And so when we're doing a combination of them, we just do them in the order they appear. So at the beginning, we just have 2 things multiplied, so that's product rule. So when we do that, we get the derivative of the first times the second function, which is just the square root of x plus 3, plus the first function, fx, or 5x, sorry, times the derivative of the second. Now this is where I'm going to have to actually do some work here, because what I'm going to do is think of it like this, and I need to take the derivative of that using chain rule. So the 1/2 has to come down, I get my x plus 3 to the negative 1/2 because I subtract 1 from the exponent. And then I multiply by the derivative of the inside, which is easy. What is it? If you look at it, what's the derivative of x plus 3?
1.
1. So I don't even need to write it. And so when I'm looking at this here is the product rule. And then this little part in here, that's the chain rule.
And that is
That's the answer.
Mister, I have a question.
The only thing that you might see if it was like a multiple choice is I would probably write it like this. Now see if you can figure out how I got to there.
Because
The
you
negative exponent.
the negative exponent.
Yep.
because you want to that.
Exactly. You cross the line and flip the sign. So that negative 1/2, I just put it on the bottom and write it as a 1/2.
Well, Mister, I have a question.
Yep.
That first part, that is 5 exponent square root x plus 3.
That's the first part of the product rule.
Yeah, but that's the prime.
Yes, we're dealing with the prime. So that's the derivative of 5x, which is where I got 5,
Yeah.
times the second function. Like if you think of this as u and v, that's the u prime v, and this would be u v prime. That's what I'm doing. Okay? Good. All right, let's take a look at the next one and see what rules we're combining.
Wait, what you be prime?
U prime v plus u v prime is what we did here. All right. What two are we combining now?
Chain and quotient.
Chain and quotient, exactly. So which one do we encounter first? Are we dividing first, or are we hitting like a trig function first and therefore chain? The trig. So that means we do the derivative of the outside. What's the derivative of sine?
What?
What's cosine? So we literally just write cosine and we rewrite the inside part. And now we're going to multiply it by the derivative of the inside, which this is where it gets complicated. And we have to do the quotient rule. So that's where we do low d high. The derivative of the top function is just 2 minus high d low. The derivative of the bottom is just 1.
Wait, Mister, what?
All right, let's finish by putting it over low squared, and then we can
But
talk about it.
what was the other derivative of the top?
So the derivative of the top was just 2,
And that one on the side.
and the derivative of the bottom is just 1, so I didn't even write it, because multiplying by 1 doesn't change anything. And so what we're doing here is our chain rule is this part, and then what's inside here, that's our quotient rule. Does that make some sense?
Yeah.
Now, guys, when you have quotient rule, that's probably the one that you need to simplify the most often, because this numerator will simplify very nicely. And so we should do that. So that means this part doesn't change, the first part. But here, if we distribute the 2, then we get 2x minus 6. And here, if I distribute the negative 1, I get minus 2x minus 1. And then you can see that that simplifies a whole bunch. So see if you can take a look at that numerator and tell me what's going on. Because something cancels outright and something else combines.
You cancel out the 2 x's
Yep,
and you combine them.
exactly. Exactly. That's exactly right. And so we'd get cosine of 2x plus 1 over x minus 3 times negative 6 minus 1 is negative 7 over x minus 3 squared.
So, Mister, the first part you do is chain reaction, right?
Yep. Well, chain rule. I knew what he meant. We knew what he meant. Chain reaction, chain rule. And then when All right, what are the two rules that we're going to apply here, guys?
The quote
Quotient
and the chain.
and the chain, exactly. Quotient because there's two things divided. Chain because we have a square root. So let's start by rewriting this function so it's a little easier to work with the square root. And we'd get 2x plus 5 to the 1/2.
Wait, what are you doing this?
It's all right.
You're doing a chain.
I'm right now I'm just rewriting the equation. Just rewriting it, that's all I'm doing. So that it's got that fractional exponent so we can do the chain rule later.
So why do we don't put the 1/2 in the front?
Not yet, because I haven't actually taken the derivative. I'm just rewriting it. If you look, those are the same thing. I just rewrote it with the 1/2, so it's easier for us to work with. Because now I'm going to take the derivative. So now I'm going to say, okay, well, h prime is low, so that's x minus 3, times the derivative of the high. That's where I'm going to have to do my quotient rule now. So the 1/2 comes down, times the something that was inside, change to the new exponent of -1/2. Okay? And then I'm going to multiply it by the derivative of what's inside, which is 2. And then I go back to doing my quotient rule. So minus high 2x plus 5 to the 1/2 times the derivative of the bottom, which is 1. So we can just leave it, right? It's just 1. And then we put this whole thing over x minus 3 squared. Now, there's at least a couple things we should quickly simplify. The 2 obviously cancels again, 2 over 2. And we don't usually leave things with this negative exponent. So let's change that. So on the top, all that's going to be left is x minus 3. And on the bottom, we're going to put that 2x plus 5 to the 1/2. Then we're going to subtract 2x plus 5 to the 1/2. And put that whole thing over x minus 3 squared. Now, you can go even further with this.
Can we leave it just on the top?
As long as you at least simplified the 2's, I would probably be okay with that. Okay, for this class, I'm okay with that.
Sir, I don't understand.
Which part?
You should be okay.
So for the first part, you just rewrite the equation, right?
Yep.
But I don't understand how, like, you form the second part.
So the second part, what I did is I did the derivative of the low.
Yeah.
Hang on. There we go. So the derivative, it's low, x minus 3, d high. This part here is that derivative of that top part. That's that quotient rule. Oh, no, sorry. That's the chain rule.
That's the chain, right?
Sorry. So this is the quotient. And so, yeah, the chain rule was just this part. So it's low, d high, go into chain rule, then go back to finishing the quotient rule by subtracting the top function times the derivative of the bottom, which is 1.
High, low.
Yes, high d low. And the d low is 1 this time, so I didn't even write it. And then we put it over low squared. Should we finish the page before we take a break? You want to take a break now? All right. All right. Good break.
Okay,
Given the graph,
I'm leaving again, listen.
of course you are. Given the graph of h of x, picture to the right, find the equation of the tangent line to this. So anytime we see tangent line, we know pot and side.
Wait, mister.
And what is the pot? Well, it's -4. And then I need to plug it into the square root of h of -4. So p of -4 is going to be the square root of h of -4. So let's go find -4. There it is. So what's the y value?
Wait. The y value
Is,
is negative.
well, x is -4, y is +4. What's the square root of 4?
2.
Good, so this is just 2. Then the trickier part, I need to find the derivative to find my SOT. So remember, this is the same as like h of x to the 1/2, right? We've talked about that. So that would be like h of x to the power of, whoops, not negative, just 1/2, sorry. So then we bring down the 1/2. Then it's h of x to the negative 1/2 times h prime of x, right? Because that would be the derivative of the inside, okay? Now let's rewrite that so that it's in a fraction form. It'll be a little easier. So that's going to be h prime of x over 2 h of x square rooted, because that's a little easier for us to work with and look at. And then I'm trying to find it at -4. H prime of -4. Well, if it's h prime, that means the slope at -4. So if you go to -4 here, what's this slope of this line?
1/2.
Close?
2/1.
No.
1/4.
-1/2, because it's going down, right? So it's -1/2 over 2, and we already did this actually. What is the square root of negative h of -4?
3.
No, it was
2.
2, right? Because it was 4, and then square rooted became 2. And so we get -1/2 over 4, and then you can either do your ear trick, or you can keep change flip. Either way, you're going to get -1/8. So to write out our equation, right, we simply now, oh, sorry, I didn't write my SOT. There we go. So it's y minus 2 equals -1/8, x minus -4, x plus 4. Yeah?
Niños, están haciendo mucho drama.
Amazing, right? All right, so our last ones here are these table questions, which I love. I think you guys know I love them by now because they really help us see if we understand what's going on. All right, so in the graph of h of x equals f of g of x, we want to know if it's increasing, decreasing, at a max or a min when x equals 3, and then we want to give a reason for our answer. So, in order to do that, the very first thing we need to do is simply find the derivative of this thing, because the derivative and the sign of it, or whether it changes, is what's going to tell us if it is increasing, decreasing, max, or min. And so that's what I need to be checking. So let's do that. So h prime of x then is going to be, this is a composition of functions, so that's a chain rule. So it's going to be f prime of g of x times g prime of x. All right. So then what I need to do is figure out what is it doing specifically at 3. So what we're going to do is go ahead and plug in h prime of 3, and we get f prime of g of 3 times g prime of 3. Now in doing that, g of 3 is going to be 4, so we're going to get f prime of 4 times g prime of 3 is 6. And then our next step is going to be to find f prime of 4, which is 8. And so we get 8 times 6, or 48, for our h prime of 3. Now, because that is a positive, that tells us what it's doing. So again, if you have a hard time with this, remember, always start with your reasoning. So we can say, well, because h prime of 3 is positive, right? Then what does that mean? That means that h of 3 is increasing. All right? And really, that's all there is to that one. Now, this next one is a little bit trickier of a chain rule here, because now we've got two different things added together underneath a square root. So the very first thing we're going to do before we do anything is we're just going to rewrite this before we even read the question, and just say, this is the same as f of x plus g of x to the power of 1/2. All right, now let's take a look. So what is the value of q prime of 4, and what does it say about the graph? So it's essentially the same thing. It's just that it doesn't list out increasing, decreasing, max, or min. It just says, what does this mean? What can we infer? So that means we're going to have to do the same thing. We got to find q prime of x first. So the 1/2 is going to come down, because this is the derivative of the outside. The 1/2 comes down. times the original inside function, so f of x plus g of x. And then we subtract 1 up here to finish that off. Then we need to multiply by the derivative of the inside, which in this case is nice and easy. It's just f prime of x times g prime of x. You need some parentheses because otherwise we're not multiplying everything and we need to multiply everything. All right. So then q prime of 4 is going to be 1/2 times, and then we need to look up what these are. So f of 4 is 1 and g of 4 is 7. So this will be 1 plus 7 to the negative 1/2 times, and now I need the derivatives of both. So f prime is 8, g prime is negative 2. So we're going to get 8 plus negative 2. Now the other thing that we should probably do is put this on the bottom so it's not as confusing. So that would mean that only this is on top. So 8 minus 2 is 6. I get the 2 down here, and then this part also goes on the bottom as a square root. And so 1 plus 7 is 8. Now from there, we can of course simplify 6 over 2 to be just 3. So we're going to go ahead and do that. And so then we're going to get 3 over the square root of 8, which realistically we should probably simplify here, although it's not really that big a deal. And we could write it as 3 to root 2. If you don't remember how to simplify radicals, maybe just go look that up because that's definitely our like pre-calc. But we could write it this way as well. Either way, it doesn't really matter because all we're asking for this time is what does it say? And either way, this is positive. So if we say because q prime of 4 is positive, right, then what does that mean? Well, that means that q of 4 is increasing because the derivative was positive. And that's really all there is. That's going to be it, guys. So then you can go ahead and do those practice problems, and we are finished with Unit 2.